The next three videos are about comets and the formation of the solar system. Comets are small, potato-shaped objects, a few hundred meters to about 20 kilometers across. They're made of dust grains and rock embedded in frozen volatiles, that is, materials that vaporize at low temperatures. Things like water, methane, ammonia, and carbon dioxide. As the comet, these nuclei are like dirty ice balls or dirty icebergs. They are primitive objects, which means they are unchanged since they solidified from the solar nebula about 4.6 billion years ago. Comets are frozen relics of the early solar system holding valuable information about the formation of the planets. When the dirty icebergs get close to the sun, they produce long gas and dust tails. Comets were usually seen as signs of upcoming disasters, even destroying the entire Earth. On the right is a scene from English history from the Bayeux Tapestry showing King Harold and officials cowering because of the appearance of Comet Halley in 1066. He took that as a sign from God that his reign was over. The Norman ruler in France, William the Conqueror, took it as a good sign that he should invade England, and his forces had no trouble running over the already demoralized English troops. In 1910, people were buying gas masks and comet pills because the spectroscopy of Comet Halley's tail showed traces of cyanogen gas, which is a poisonous gas, and the Earth was going to go right through the tail in 1910. Now, in actuality, the tail gas is very rarefied or diffuse, so there was no danger of being poisoned. The 1997 episode of the Heaven's Gate mass suicide associated with the comet Hale-Bopp shows that comet superstition is still very much alive and well. The four components of comets when they get close to the sun are shown in the picture on the right. When the comet is far from the sun, it is just the nucleus, the dirty iceberg, in deep freeze. The four parts are the nucleus. This is the usually frozen iceberg from where all the material comes. It's the usual state of the comet when far from the sun. There's the coma, which is the atmosphere around the nucleus that forms when the comet nears the sun at around the Saturn to Uranus distance from the sun. The ion tail is made of charged particles. The bluish color is from the emission line spectra, mostly ionized carbon monoxide. The solar wind stretches the ion tail so it points directly away from the sun, and it forms at about Mars's distance from the sun. And then the dust tail, which are made of dust particles, well, like the size of cigarette smoke particles, that curves away from the sun. Sunlight pushes on the dust grains, so it has a yellow-white color from reflected sunlight. On the left is an animation of a comet in its very elliptical orbit. You'll see that the two tails form at about Mars's distance from the sun and always point away from the sun, so on the outward bound part of its orbit, the tail goes ahead of the comet. You see also that the comet spends most of its time in the outer part of the solar system far from the sun. The animation speeds up time when the comet is far out and slows down time when the comet is in close. Real comets spend decades to hundreds of thousands of years in the outer part of its orbit near aphelion, because that is where they are moving the slowest, and just a few months in the inner solar system where we are because they are moving much faster. Kepler's second law of orbital motion describes this behavior of orbital velocity. Let's take a closer look at the comet nucleus, the dirty iceberg from which all the material comes. Comet nuclei are half a kilometer to 20 kilometers in size and are potato-shaped conglomerates of dust, made of silicates and carbonaceous stuff, embedded in ice, that is, frozen water, carbon dioxide, carbon monoxide, methane, and ammonia. They are tens of billions to hundreds of billions of times less massive than the Earth. From the Earth, a comet nucleus is too small to be seen, so we have to send spacecraft up close to see what it looks like. The lecture slide shows the comets we have seen up close, starting with Comet Halley in 1986. The nucleus of Halley's comet has dimensions of 8 by 8 by 16 kilometers. The nucleus of a comet has a density of only about 0.1 to 0.25 times the density of water, and it is very dark. It reflects only 4% of the sunlight. That's less than what coal does, which is about 6%. The density is about that of a loosely compacted snowball, and it is quite fragile. You could break a piece of the nucleus in two with your bare hands. There are surfaces of old, pockmarked areas right next to young, smooth areas, and the craters are from impacts and from jets of volatile material that sublimes, that is, turns from solid to gas with no liquid state in between, when the comet gets close to the sun and warms up. The side of the nucleus facing the sun warms up enough for the volatiles to sublimate and jet outward. Be sure to check out the link to the Rosetta website about the first comet mission to orbit and land on a comet as it orbited the sun.